Hi everybody, today we'll be finding the needed sample size for proportions of means. Let's start with an example. A tech company previously surveyed a small group of users and found that approximately 70% preferred dark mode over light mode in their app. The company now wants a more accurate estimate for this proportion. How large of a sample is needed to estimate the true proportion within 4% with a 99% confidence? The equation we use to find the sample size is z alpha over 2 squared p prime times 1 minus p prime over the error bound of the proportion squared. In this case, p prime is 70%. Our error bound of the proportion is 4%. Right now, this gives us that n is z alpha over 2 squared times 0.7 times 1 minus 0.7 over 0.04 squared. We are going to use Minitab to find the value of z alpha over 2. In Minitab, I'm going to hit Graph, Probability Distribution Plot, View Probability. We're using a normal distribution, but I want to go over to my options and say I'm looking for a specified probability and I'm looking for equal tails. The probability, because we're doing 99%, is 1 minus 0.99, which is 0.01. In the graph, we can see the 1% split into 0.005 and 0.005. What we need to grab is the 2.576, which is z alpha over 2. This says n is 2.576 squared times 0.7 times 1 minus 0.7 over 0.04 squared. Put that all in your calculator. It gives you 870.95. You're going to round that up to 871. Don't let the rounding confuse you. This time it was really close. 870.95 is really close to 871. But all rounding for sample sizes will be up to the next whole number. So even if this had been 870.01, I would round it up to 871. Our second problem says a company wants to determine whether customers prefer the new version of their website interface over the previous one. What sample size is needed to estimate the proportion of customers who prefer the new interface with a margin of error of 2% and a 95% confidence level? We will use the same equation to find the sample size because we're still using a population proportion. This time, we're not given an estimate of p prime. Anytime that happens, we use 0.5 for p prime. This time we have a 2% error bound of the proportion, so let's put those two values into our equation. Now we have z alpha over 2 squared is 0.5 times 1 minus 0.5 over 0.02 squared. Again, we're going to go back to Minitab to find the value of z alpha over 2. This time our confidence level is 95%. So we'll go back to Graph, Probability Distribution Plot, View Probability. On the options, we're going to change the probability to 0.05. We had a 95% confidence level, so that says alpha is 5% or 0.05. Because we're looking at equal tails, that means it's going to do alpha over 2. We expect 2.5% on the right and on the left. In our picture, we see our 0.025 that we said we would get, and we find our value of z alpha over 2 to be 1.960. Putting that into our equation, we have 1.96 squared times 0.50 times 1 minus 0.50 over 0.02 squared. This comes out to a whole number. It's 2,401. Our last problem says a manufacturer wants to estimate the average time it takes for users to assemble a piece of furniture using a new instruction manual. Previous studies suggest the standard deviation of assembly times is approximately 12 minutes. How many users should be included in the sample to estimate the mean assembly time within 3 minutes with a 90% confidence? Because we switched to a mean, we have a different formula. Now we have n is z alpha over 2 squared times sigma squared over the error bound of the mean squared. The previous study said the standard deviation is 12 minutes. We're going to use that for our sigma. We have an error bound of the mean of 3 minutes. Now we have z alpha over 2 squared is 12 squared over 3 squared. Of course, we're going back to Minitab to find z alpha over 2. Remember, this time our confidence level is 90%. Back in Minitab, I again hit Graph, Probability Distribution Plot, View Probability. On the options, I am changing the probability to 10%. My Z alpha over 2 is 1.645. Now we have 1.645 squared times 12 squared over 3 squared, which is 43.2964. Remember, we are always going to round up to the next whole number, so this 43.2964 will be rounded up to 44.